Hello friends, in this video I will explain some rules related to set algebra and boolean algebra also, and Cartesian product. Okay, so let's start. So the first thing which is I'm going to explain is the rule sets, which I have already explained here. You know what, in summary I have written so that overview I can give to you all. First, you can see here, this is as heading it is written summary of operational rules in set algebra. Okay, so set algebra, it is different from the normal algebra because some rules of set algebra it is different. Okay, so I will explain. So this is the rule. Okay, and the algebra which satisfy these all rules known as boolean algebra. It means set algebra obeys or work according to boolean algebra. Understood? So this is so first of all closure problem. So here some rules are given, 9 rules are given about set algebra or boolean algebra you can say, because set algebra is the algebra which work on boolean algebra. Okay, rules of this boolean algebra it is different from the normal algebra. First, a closure property. So a union b, about union I have already explained, and intersection also I have already explained. Okay, so according to closure property, so union of two sets, so a union b is a set, means union of two set will be a set. Okay, and the intersection of two set will also be a set. Then second, associative property also I have explained that now you can change the order just like here, a union. So here all rules are about union, and here all rules are about intersection. Okay, so here you can see a union and b union c. So here first we are doing uh, b union c because b union c is in bracket. Okay, then after we do the function of union of this with a. Okay, and in the right hand side, here it is given first we have to do the union of a and b, and then after with same. So it means we can change the order in which we are doing union. In the same way, in case of intersection also, okay, we can change the order. And then after commutative, commutative means a union b or b equals b union a. In the same way, b union, or sorry, a intersection b, a equals b intersection a. Okay, then after distributive properties, so in this case what happens here, we can remove, means here a union and then after inside bracket b union c, so then we can remove this b outside. Okay, and then we can put the a union b into bracket, so that's you can see here. Okay. Then after it is given union, and then inside bracket here it is written a union c. Okay, in the same way it is for the intersection, and in important rule says that a union means union of, if union is of the same set, then in that case you will get the same, means a union a you will get a. Complement means here a union a complement you will get universal set, and if intersection with complement, then you will get null set. In the same way, De Morgan's law I have already explained about this, and involution here 2 times complement you will get the same set, and bounds here it is given in the ninth one. So here union with 5 you will get the same set. Here a union universal set you will get universal, and then if it is with if it is intersection, then opposite will happen. Intersection with 5 you will get 5, and intersection with universal you will get the same set here. Okay, and these all things I have already explained. Okay, simply here summary it is given. Then next here it is given that boolean algebra. Okay, So here given, if the algebraic operation with certain entities satisfy the set of rules set out in the above table. So whatever rules are given in the above table. So if the algebraic operation satisfy these all rules, means the rules which are given above, so then that algebra is known as Boolean algebra. Okay. So here rules are different from the ordinary algebra. That's I have already explained. Now here number of elements in a set. So how to find out? Okay. So if you have to find out the number of set, so now you can see here. Generally we use plus for union also. Okay. So here n for number of a union b, here we can write like this. This is the formula which you can apply for finding out the number of elements if you are finding the union of two sets. And in the same way here, the number of union of three sets you can find out by using this formula. Okay. Explanation right now it is not necessary. If you people want uh, to not make me videos on explanation, okay, how these results came, then you can write in the comment section. I will definitely make videos on those topics. Then after next come to ordered pair. So as you already know, in case of set, the order or the order of elements doesn't matter. Just like here a comma b equals b comma a, because here you write down first or last, so it is not going to affect the set. Okay, this is in case of set. But if it matters, when if matters, then that is known as ordered pair. Just like if a comma b is not equal to b comma a, then such type of arrangement is known as ordered pairs. Okay. So here in technical term, here it is written the set of pairs of x and y, that is x comma y, such that the x from capital X, this x capital X is the set, or I mean here it is x belongs to x is a first and y is the second element. So here x and y, x is the first element and y is the second element. Then in that means if two sets are given, if x is the first set and y is the second set, then the elements of x will be will the first element of the pair, and the elements of y will be the second element of the pair. Okay. So such type of pairs are known as ordered pairs. Okay. So we will use this when I will explain about the practical application of ordered pair, so where it is used. Okay. So now next here it is Cartesian product. So the set of all distinct possible ordered pairs. Okay, the set is Cartesian product is the set of all possible ordered pair of the form x comma y, where x belongs to the set A x and y belongs to the set y, is known as Cartesian product. Okay, I will explain by giving example. Here example given. For example, let set x equals a comma b and set y equals x comma y. So here two sets are given. So if we have to find out the Cartesian product, so Cartesian product xy, it is going to be the, now you can see the first element of all these pairs should be the element of x. So now you can see here a comma x, a is the element of set x and x is the element of set y. In the same way here you can see b, second pair, b is the element of x and x is the element of set y. In this way, so we can write like this. But if we change the order, now you can see here it was x into y, now here it is y into x. Now in this case what is happening, the first element which I have to write down is the element of y. So now you can see in these all cases the first element belongs to the set y and the second element of all these pairs belong to set x. Okay. So this is it. So why, what, we use Cartesian pairs, and what is the significance of Cartesian products? So that I will explain. So first here it is, by example I will show you that how, what, a means x into y is not equals to y into x when we consider about the Cartesian product, okay, or the ordered pair. So here you can see here one example I have taken here. Set A contains two elements 1 and 2, and set B contains elements 1 2 3. Okay, so if we have to find out the Cartesian product, so now what do we have to do? Simply AB. So AB means the first, now you can see in this all ordered pair. So Cartesian product, that I already explained, is nothing but uh, the the ordered pairs of the sets. So now here two sets A and B. So the first element should belong to set A, and the second element should belong to set B. So now you can see here in these all pairs. So it is like that. So one. So this one, the first element of this ordered pair belong to set A, and the second element one belong to set B. In the same way, the first element here for the second set belong to this, and this two belong to set B. In the same way here for third, this first element belong to set A, and the second element belong to set B. Okay, so in this way we can write down Cartesian product AB, and in this, on the same principle we will find out the Cartesian product BA. So Cartesian BA meaning, so we have to write down the first element from set B, and the second element from set A. So now you can see here 1. So the first one, it belongs to set B, and the second one belongs to set A. Then in the second pair, the first element, this one belongs to set B, and the second element belongs to this set A. Okay, in the third one, the first element belong to set B, and the second element belong to set A. Okay, so this is the way we can find out. So these two are different. So this Cartesian product of these two sets A and B are different. How? So when we represent this by using graph, then you will see, we will get different patterns. Okay, so this first graph you can see here, this is about AB. So A I have taken along x-axis, and B I have taken along y-axis. Okay, so if we find out the Cartesian product, we have already found. So now we have to represent those all what, ordered pairs here on this graph. So now you will see that these patterns are different. So first of all, here it is 1 comma 1. So 1 comma 1 here, and then after it is 1 comma 2. So 1 comma 2 here, then after 1 comma 3. Now you can see here 1 comma 3. So 1 comma 3 here. In the same way, so remaining 2 comma 1, 2 comma 1 here, 2 comma 2, 2 comma 2 is here, 2 comma 3 here to 2 comma 3. Okay, so this is about AB. So AB means whatever we write down first, now that we have to represent along x-axis, and whatever we write down in the second, so that we have to represent along y-axis. So that's why A I have taken along x-axis, and B I have taken along y-axis. Okay, clear? Then after BA, now I'm representing BA by using another graph. So now you can see the Cartesian product here it is 1 comma 1. So 1 comma 1 here it is. So 1 and then 1. Okay, so first element will represent the distance along x-axis, and the second element will represent the distance along y-axis. Okay, then after the second, it is 1 comma 2. So 1 comma 2 here, the first element should be what, along x-axis, so 1, and then after it is given 2. So 2 means here, so this is 1 comma 2. Then after third element, it is 2 comma 1. So 2 comma 1, so 2 along x-axis, so 2, and 1, 2 comma 1 there it is, then 1 along y-axis, so y, so 2 comma 1. So here you will reach. In the same way you can find a 2 comma 2. So 2 here you will get, and then 2 along y-axis, so here you will reach. So if we plot these all points on this graph, so you will get this type of pattern. So now you can compare these two patterns. So these two patterns are different from one another. Okay, So that's why the Cartesian product of a b, you know what, when we change the order, then will result different product value. Okay. So this is it. In the next video I will explain about the relation and function. Okay, so thank you all. So please don't forget to like, subscribe and share, and press the bell icon to watch such informative videos related to mathematical, statistic, finance. Okay, thank you.